guys, so in this video I'm going to go over how to take even power trigonometric integrals because they're different when it's odd power. So that's why I decided to do this in two separate videos. So the first thing I do want you to do is I want you to make a note of this right here. Identify whether one of the trig integrals has the odd power. If even one of the however many trig functions you have has the odd power, then you apply the odd power trig integral steps. Otherwise, if they're all even power, then you apply the even power trig integral. So in this case, cosine to the fourth power is the only trig in this one, and it has all even power, so we apply the trig integral even power. So without further ado, for step one, we're going to break down the exponent. So cosine to the fourth power can easily be broken down to cosine squared times cosine squared. And for step two, since there's no odd powers and there's only even powers, we're going to apply the power reducing formulas. And it's these right here that I do want you to familiarize yourself with, because this is what we use when we're taking even power integrals. So in this case, we have the power reducing formulas. We know sine squared is equal to 1 minus cosine 2x divided by 2, and we know cosine squared is equal to 1 plus cosine of 2x divided by 2. So these are called the power reducing formulas. So what we're going to do right here is we're going to write down what we have. So we know we have cosine squared. We don't have sine squared, but we do have cosine squared. So we know cosine squared is equal to 1 plus cosine 2x divided by 2. And the integral that we currently have is cosine squared x times cosine squared x times dx. And what we're going to do is we're going to substitute in the power reduced formula in for the current trig integral that we have. So we're going to apply the substitution. So cosine squared can be substituted as 1 plus cosine 2x divided by 2. And since we have two of them, we're going to apply it a second time. 1 plus cosine 2x divided by 2 times dx, of course. So now what we're going to do, now that we have, we're going to factor it out and simplify using algebra. So we had 1 plus cosine 2 theta over 2. And all I simply did right here was I factored out the 1/2 out of both of them. And I'm left with this right here. So 1 plus cosine 2x divided by 2. Since each one of them is being divided by 2, I factored out 1 over 2 times 1 over 2, which is 1 over 4. So now that I've done that, what I'm going to do is I'm going to simplify this by just multiplying each term. I'm going to FOIL this one out. So 1 plus cosine 2x plus cosine 2x plus the last terms being multiplied are cosine squared 2x times dx. And of course, I'm going to underline these two terms that are alike. So then I can then simplify this to be 1 plus 2 cosine 2x plus cosine squared 2x times dx. So now I'm going to apply the power reducing formulas a second time because we have cosine squared 2x. So for this term right here, we're going to apply the power reducing formula again. So we have cosine squared 2x, but keep in mind this is cosine squared 2x, not cosine squared x. So instead of 1 plus cosine 2x, this is going to be 1 plus cosine of 4x divided by 2. Why is it 4? Well, because we have a 2x right here where my mouse is, and we do not have an x. If we had just x, it would be cosine 2x, but since we have 2, we're going to multiply by 2, so it's going to be cosine 4x. So this term right here should always be double of what this term is right here where my mouse is. So now that we have that understood, we're going to substitute it into the integral. So 1 over 4, 1 plus 2 cosine 2x plus 1 plus cosine of 4x times dx. And now we're just going to join the like terms. So we have 1 plus 2 cosine 2x plus 1 over 2 plus cosine of 4x over 2 times dx. And now we're going to simplify the like terms. So we know 1 plus 1/2 is 3/2. And we have plus 2 cosine 2x plus cosine of 4x over 2 times dx. So now what we're going to do is we're going to go ahead and make sure each term has a common denominator so we can factor out. Makes it easier for the integral. So that's why I'm multiplying cosine of 4x over 2 times dx. So basically what I did here was, notice how this term where my mouse is and this term where my mouse is have a common denominator of 2, but this one does not. It has a denominator of 1. So all I did was multiply the top and bottom by 2 over 2, and now they all have a common denominator of 2, which we can factor out. So we're left with 1 over 8, the integral of 3 plus 4 cosine 2x plus cosine of 4x times dx. So that's why I like to have common denominators, so that way I can factor them out. So now what I'm going to do is I'm going to integrate the function. So this is our function, and what I'm going to do is I'm going to break it into separate integrals to make it easier for myself. So I have 1 over 8 on the outside, and I have 3 dx plus 4 cosine of 2x dx plus cosine of 4x times dx. So all I do is just break up the integral into 3 separate integrals, and it makes it easier and less error prone whenever you do it this way. So now I'm going to integrate each term respectively. So in the yellow brackets, the integral of 3 dx is 3. I'm going to factor out the constants, and 4 times cosine of 2x dx in the blue brackets, and in the pink brackets there is no constant to factor out, so I can just leave it as cosine of 4x times dx. And now I'm going to integrate this. So 1 over 8, the integral of 3 dx is 3x. The integral of cosine of 2x is sine of 2x divided by 2. And of course this is within the 4. And the integral of cosine of 4x is sine of 4x divided by 4. And of course yellow, blue, and orange, and pink. So now I'm going to simplify this. Plus c, of course, 3x over 8 plus 4 over 2 is 2. There's 2 over 8, which is 1 over 4, because now I'm distributing the 1/8 to each term. This 1/8 term over here, I'm distributing it to each term, so I get 1 over 4 sine of 2x plus sine of 4x divided by 32 plus c. And that's how we do this problem. So now in this example, we have sine squared times cosine squared times dx. And for step 1, we're going to apply the power reducing formulas as we did in the other problem. And same note, we want to identify the trig integrals, whether it has an odd power. If it has even one odd power, then we apply the odd properties. Otherwise, if they're all even powers, then we apply even power properties. In this case, notice that sine squared times cosine squared, they're all even powers. So we're going to go ahead and apply all even power properties. So now let's apply the power reducing formulas since it's all even powers. So keep in mind, power reducing formulas, we know cosine squared x is 1 plus cosine 2x over 2, and sine squared x is 1 minus cosine 2x over 2. So we're going to substitute these into the current formula. So we're going to substitute, factor out, and simplify using algebra. So we know sine squared x times cosine squared x times dx. We're going to substitute for sine squared x, 1 minus cosine 2x over 2. And for cosine squared x, it's 1 plus cosine squared x 2x over 2 times dx. And now what we're going to do is I'm going to factor out the 1 over 4, because I can factor out 1/2 out of each term, then I multiply 1/2 times 1/2, and it's equal to 1/4. And I'm left with 1 minus cosine 2x, 1 plus cosine of 2x times dx. So now I'm going to simplify this. I'm going to FOIL these out. I'm left with 1 minus cosine of 2x plus cosine 2x minus cosine of 2x squared times dx. And all I did right there was just FOIL it out. And I know these two inside terms will cancel each other out. So in essence, I'm left with 1 minus cosine squared 2x times dx. So what I'm going to do now in the next step is I'm going to apply the power reducing formula again a second time for this term right here. For the cosine squared x, I'm going to apply the power reducing formula. So what I'm going to do for that is I'm going to cosine squared 2x is equal to 1 plus cosine squared of 4x over 2. And I know 1 over 4 is equal to 1 minus, I'm going to substitute it in, a 1 plus cosine of 4x over 2. So now we're going to simplify this using algebra. So we know 1 over 4 is 1 minus 1 half over cosine of 4x plus 1 half. And when I simplify this, I know 1 minus 1 half are like terms. And then cosine of 4x over 2 times dx. So when I simplify 1 minus 1 half, that's equal to positive 1 half plus cosine of 4x over 1 half, or divided by 2, basically. And I can factor out a 1 half. I can factor out the 1 half, the denominator, the 2, and I get 1 over 8, because 4 times 2 is 8. And I'm left with 1 plus cosine of 4x times dx. So now I can integrate this. So we're going to integrate the current function, and I know 1 over 8. When I integrate 1 dx plus cosine of 4x times dx, I'm going to separate it into different integrals. And when I integrate this, the integral of 1 dx is x, and the integral of cosine of 4x is sine of 4x divided by 4 plus c. So now what I'm going to do is I'm going to distribute the 8. So I'm going to simplify this by distributing the 1 over 8. So I get x over 8 plus sine of 4x over 32 plus c. And that's the final answer. So I hope this video was helpful. I think the key is you have to really understand when it's even and when it's odd. So if all the terms are even, then you apply the power reducing formula. If you have even one term that's odd power, then you apply the odd power properties. So you would apply the other substitutions, the trig identities. You would apply the trig identities, the Pythagorean identity substitutions. But if they're all even, then you apply the power reducing formula. And from there you just execute. And sometimes you have to do it more than once. Thank you for watching. I hope this video was helpful.